Welcome to Server-Side XSS scripting. My name is Bucsay, and I'm going to bore you a little bit with my life. So over the past 2 decades, I was doing offensive security, and in the past 15 plus years, mainly I was focusing on consultancy and research. I'm also a software reverse engineer. I just had a workshop yesterday here underground. I started to learn assembly when I was 13 years old, and then I had quite a lot of fun with that. For fun, I go around the world and do different talks on different conferences. I've been to the US a couple of times, obviously around Europe, and even in the APAC region, Philippines, Singapore, and Australia. I think I'm quite a friendly guy, so if you want to chat with me after the talk, I'm up for it. I'm going to be here for lunch for sure. Here are a few topics that you can start the conversation with. Obviously, IT security, that's why we are here. But other than that, I love to do sports and traveling as well. I've been to more than 75 countries so far, and my soft goal is to go around the world and visit every country. Fun fact, I kayaked the length of the Thames last year. I went from the source to Greenwich, and I spent like 9 to 10 days on the river. You can find me on Twitter, on LinkedIn as well, and the same goes for my company. Just send me a request or follow me if you like. So that's me on the Thames, under the Tower Bridge, which was pretty cool. It gives a different view of the city, for sure. A little bit about my company. I started Monitor Information Security almost 2 years ago. It's a boutique consultancy. We do all kind of IT security services, including penetration testing, web application, web API testing, training delivery. We have a really cool training. It's called Software Reverse Engineering. We can teach you how to do reverse engineering from scratch in a few days. So hit up the website if you are interested in one of these services, or the training, or just reverse engineering in general, and you will find a few bits of information about the company and me. So let's talk about the gist, server-side cross-site scripting, which might be a strange one. This is definitely a mouthful. It's hard to even pronounce it, to say it. So let's talk about that a little bit. First of all, I would like to start with cross-site scripting. Everybody knows cross-site scripting. This is the most well-known attack vector vulnerability out there, and I'm pretty sure this is one of the most misunderstood as well. If you see this window, you have cross-site scripting on your website. This is usually how it's presented in reports. So, what's cross-site scripting? Basically, it's a type of injection attack. If you have a website and you can inject malicious or any kind of HTML, JavaScript into the website, then you have a cross-site scripting issue. There are different types. I'm not going to talk too much about cross-site scripting in general, but they are stored, reflected, and DOM-based, and it's always executed in the browser. But that's the question. Is it always executed in the browser? Is it a yes? Is it a no? So there are basically 3 different root causes why you have cross-site scripting in your website, and if you choose one of these and implement one of these, you won't have this issue. So improper input validation, improper input sanitization, or improper output sanitization. If you have all these, if you have all 3 missing from your website, then you will have input injection issues, including cross-site scripting. If you implement one of these 3, not the improper ones, the proper ones, then you will be safe against these kind of attacks. So I told you that cross-site scripting is one of the most misunderstood injection attack out there, and the reason why, because nobody understands the impact behind that. So whenever we are talking about a report that is created by a consultant like me, probably I'm not the best example for this, but anybody who is doing consultancy usually find these kind of issues and create a report. Then they just put that alert 1 or similar window into the report. You get a screenshot, and they tell you that you have a cross-site scripting, and we can create a window out of your website. So you wouldn't really understand what's the impact behind that if you're not technical, if you're not a security consultant or a geek. which is fine. Not everybody is like that. But the point is you can do a lot more than that. Obviously, a consultant doesn't always have time to do full impact, but there are a few other things that you can do, well, quite a few other things that you can do from cross-site scripting, including user impersonation, account hijacking, where you can steal the cookie. You set that cookie in your browser as an attacker, and you can impersonate the user. You are logged in. You don't need the username. You don't need the password. Sometimes you don't even need the second-factor authentication if the website requires one. You can do whatever you want with the impersonated user, which is a bigger impact than having a window on the website, right? So that speaks for itself. You can do website defacement. You can just redress the UI, you can change the pictures, whatever you like. You can do everything from JavaScript if we are talking about a website. And there is always the phishing attacks as well. So if you are working for a bank, if you have an organization which is attacked by scammers, attacked by ransomware operators and whatever, and they can do defacement, they can find the cross-site scripting on your website, they can do phishing attacks against you. So they send an email, you click on the link because it points to your website that you trust, and if there is a cross-site scripting vulnerability in your website, they can redress it, they can put some kind of login form on your website, and they can get your username and password if you type it in. And you might type it in because it's a trusted website, it's your website, but if there is a vulnerability in that, they can control the content, right? So that's a lot bigger impact than just having alert one window in your browser. So again, these kind of vulnerabilities, cross-site scripting, most of the time it's really, really trivial to find, and that's why it's really misunderstood and underestimated. So I also mentioned that it only affects the client's browser, right? Well, we are going to talk about that in a bit. So I want to be sure that you understand, even though I'm talking about JavaScript and HTML, I'm going to talk about cross-site scripting mainly. Well, purely. This is something else, so I purposefully choose the title for this talk to be server-side cross-site scripting instead of JavaScript injection, because JavaScript is everywhere. So obviously we have it in websites, we have it in web servers. So if you think about Node.js, you can create websites on the server side from Node.js, which is based on JavaScript, or there is Electron, and you can use JavaScript to create desktop applications, right? Well, I'm not going to talk about these things, but I wanted to mention it here. So basically, if you can do JavaScript injection in websites, you get cross-site scripting. That's what I'm going to talk about. But there is JavaScript injection in Node.js where you can do remote command execution, or in desktop applications, Electron, where you can do remote command execution again from JavaScript. So there is quite a variety behind the JavaScript injection, but we are going to talk about the first thing, cross-site scripting in web applications. So I mentioned already that cross-site scripting runs in the browser on the client side, right? Is it always the case? Well, not always the case, because sometimes the browser runs on the server, which is quite a strange thing to think about, but it happens. So why does it happen? There are multiple reasons, but the main reason that I find these days is that more and more web applications have this feature where there is a button, and when you click on the button, you get a PDF. And that PDF will have the same website or part of the website. If you think about your internet banking, you can log in and you can see your statement, right? And there is a button to download your statement, and you get a PDF file which is going to have all the spending and income transactions that you have, incoming transactions that you have in your bank. So you get the same content in the web browser, and you can get the same content in a PDF if you push a button. So somehow that PDF needs to be created, and there are multiple ways to do that. In the past, it was more like developers started to understand how PDF works, HTML, how to render that using a software library, but that took a long time. So there is a different approach to do that these days, and this is more like the agile approach, where you move fast and break things. Probably heard that already. But with the issue with this approach, and the diverse technology stack that we have out there, that developers just copy-paste everything from everywhere, use parts from here and there. And for example, if you think about this technology set, stack, Docker, Chrome, and HTML. If you think about Docker, that's a well-established technology. It's quite secure. Obviously, you can misconfigure it, but by default, it's quite secure. There is Chrome, which is one of the most secure browsers out there. And there is HTML, which is a well-established standard. It's with us for a long time and is going to stay with us for a long time. And there is PDF as well, which is like, it's okay, but let's say it's secure, right? So if you add these three and you get PDF out of it and everything is secure, then the solution should be secure as well, right? That's what you would think. But most developers don't think about these things because they are not security specialists, so they make mistakes. So my approach is probably the first one, but that's not how the world works anymore, which is fine. But my point is that with the faster pace and with this agile approach and moving fast and breaking things, we definitely break security as well, and that's not helping our environments. So I've seen this in real life multiple times. I had these issues in quite a few engagements so far. So I was thinking maybe I can do a presentation on it. And a good presentation, well, I like to have a presentation with demos usually. So I put together a demo, and here what's going to happen is basically I created an environment in AWS, Amazon Web Services, where there is a website where you can submit HTML content and you get a PDF back. It's going to run on Docker, ECS, Fargate, ECR services if you want to know it in depth. And there is a little bit more in the background that I'm going to talk about. So I was looking into these Docker solutions where you have this Dockerized container that you can use to generate PDF from HTML. One of the first Google results that I found was this export HTML GitHub repository. You can find it really easily if you Google it. And it was perfect for my reasoning for this presentation. It's a Docker container. It does what I want it to do. It basically creates an API that you can post HTML into, and it returns a PDF to you. So what could go wrong with it, right? Well, we will see that. But before I go into the details, I want to note something here. So if you open this repository, it hasn't changed. There is a one-liner security note, which I find really cute. This is totally right. I fully agree with it. It says, this is intended to run as a microservice. Do not directly expose it to the public internet. And that's a really good note, right? You shouldn't expose it to the public internet. But the issue with this is just a one-liner. So there are quite a few other things that you could add. For example, I would disable JavaScript. I would put this Docker container into a fully isolated firewall environment, so it wouldn't be able to access anything else on the network. And also, you might want to validate and sanitize all inputs that are going into the container, right? Because I told you, if you have improper input validation, input sanitization, and output sanitization, then you are going to have issues. So, I like to be fair, so I went on GitHub, and then I opened a new issue about security implications, and I detailed that maybe that one-liner security note, which is quite cute, should be expanded a little bit. Here are the things that I would put in there. Maybe you can do a little bit of research on that. And I understand that nobody has responsibility in this case, but if you publish something on the internet, because you want to help people, you might want to do the extra mile and add a few extra security features, because people will get those containers. They're just going to clone the repository and they will use it as is. They won't care about security. And the more people use the same repository that is vulnerable, the more issues we are going to have in different products. So, yeah, I didn't expect much from this issue that I opened, actually it worked out really well. I got 2 likes, so that's basically the implication. Well, that's the impact that I managed to got from it. And also, I need to note that one of the likes was by myself. So that's that. So what I did, I created an environment which I thought is going to be really trivial. But if you use cloud products, then you might realize that this is not that straightforward if you want to do it quick. Actually, I don't think you can do this quick. So I created IAM roles, policies, VPCs, subnets, routing tables, internet gateways. I deployed 2 different containers with ECS, with Fargate, and I configured quite a few security groups as well to have this environment for this presentation. There are 2 containers. I already told you. One is the export HTML. With that, you can render PDF from HTML. Not that surprising. And the other one, I built a custom one just to make it more enjoyable and just to make it more real life. Obviously, this custom build was purposefully built vulnerable, so it doesn't really count. But you can find the same issues in the wild in real life. So I wasn't really cheating there. So the custom built one has 2 different issues. One is LFR, local file read. So you can read any file with that vulnerability from the local file system. And the other one is SSRF, which is server-side request forgery. So you can send HTTP requests to any services on the network, or maybe to the internet as well. So let's see the demo. Sorry, too many windows. So this is the website. I don't think you can access it. This is the Docker container. And this is usually what you see. But if you know a little bit more about this, I thought I changed it. Or it didn't change the one. Oh. Okay, maybe let's see the video for this one. So here you have the Docker container that I was talking about. It's working, it's accessible from the internet. And in Burp, you can send a post request to it. So that's what I'm going to do. This is the endpoint. And you can see the content there, which is HTML body, hello. It basically creates a website which says hello there. Now we send it. It says 200 OK, so it was generated, and you can see it's a PDF file. That's the content. It even says that it was built, it was created on Linux, and it's a headless Chrome, so basically a Chrome browser without a GUI. And if you save the content that was returned into a PDF file, you can open it in a browser. There you go, and that's the rendered PDF, right? So from HTML, you could create a PDF file, which basically the same content that you would expect in the browser. So that's what I wanted to show you in Burp, but it didn't work out really well because of the font size. And then there are different payloads that you can try against. So I have a set of payloads here. Can you read it in the back? Perfect, thank you. Yeah, so this payload is basically another HTML. All the payloads are going to be HTML and JavaScript. This one creates an iframe that points to my website, mantrainfosec.com, and going to load an HTML file. So I wrote a script. This is the script. It's just going to help me to execute these payloads. It's going to be sent to the server in JSON format. So here in the terminal, I'm just going to send to that IP payload 1. Okay, that happened. And in the file view, you can see there's a PDF file. So when I open the PDF file, you can see this frame here, because it's an iframe. And inside the iframe, I have my logo and a bit of my website. So what does that prove us? Basically, it proves that the browser, the headless Chrome browser on the server side, has internet access. I could connect to my own server from that Docker container. So basically, I can render any website from that Docker container from the internet, right? So the next thing that I want to check whether it has JavaScript enabled. So what I'm going to do, I'm going to use that payload or a similar payload. Oh, oops, not that one. Payload 2. So you might see this. It's a script. It's a JavaScript where we write some content into the website. It's going to be a number. And if you execute it and you see the number, you can be sure that JavaScript is running on in the browser, so it's not disabled. So let's say payload 2, and that's the number, right? That's basically what we expected. So now we know that it has external internet connection, and it runs JavaScript as well. So let's see the back to the slide. So we know that basically we can do cross-site scripting on the server side. We can render any kind of HTML and JavaScript. Whatever we want is going to work. So what can we do from a browser? What can we do with JavaScript? What can we do with cross-site scripting, right? So there are quite a few things. For example, you can reference SMB shares, and you can do SMB relaying, or you can capture the hashes. Other than that, you can do SSRF, port scanning, you can access cloud-related metadata, read local files probably, maybe, sometimes, and do denial of service. So the first thing is, this one only works on Windows. So we saw that the Docker container is running on Linux. It was in the PDF header. So this is not going to work for us, but if the Docker container runs on Windows for some reason, or we have a similar situation on Windows, you can do SMB relaying, or you can steal the hashes and you might be able to log into the server. So that way you can do remote command execution on the server right away. Obviously it's not that trivial, but you can do that. In our case, it's not going to work because it's running on Windows. There is another one, local file read, which might be really useful if you are using Linux. You might be able to read file like etc password or etc shadow, depends on the privileges that the browser has. Well, this only works if the same origin policy allows it. So what's same origin policy? Basically, if you when you try to open a file or a website, it only allows you if the origin is the same as the target. So here you can only read files if the payload comes from the file. So if whatever I send to the server, to the Docker container, is written into a file, and that file is being opened by the headless Chrome browser, then you can do local file read. I need to note that about blank doesn't count as a file. So we will see later whether we have local file read or not. I'm going to do the demo for that. There is denial of service that you can do, but I prefer not to do that because it makes no point for me. I don't like to do harm. But if you are evil or you are a black hat hacker or ransomware operator, you might want to do this, and you can create a huge financial impact on the owner of the AWS resources. There are quite a few ways to do that. Okay, so the next one is cloud metadata. Hands up if you heard about these. Okay, some of you. So basically, if you are using cloud, GCP, AWS, or Azure, then you have these metadata hosts. It seems to be universal between these three, across these three cloud providers. The metadata can be useful, and sometimes it stores really important and useful information like username, passwords, different credentials, private keys, and so on. So if we are talking about AWS, you have the metadata under that IP, right? There are two different ways to access it. The first one is EMDS version 1. This is the old one. They try to deprecate it because they realize it's not a good idea to have it like that. Basically, it's a simple request response method. So you send a request to that website and it returns the value. So it's really simple. There is the EMDS version 2, which is a newer version. This is pushed on everybody now, which is the more secure version. Here you need to send a put request first. You get back a session ID. And then you need to send that section ID as an extra header with the follow-up GET request. So the thing with this that you can't do this from HTML itself. You can kind of do that from JavaScript, but because of course it's not going to render. And it's only relevant on EC2, and we are using ECR, which is for Docker containers. So let's check the next payload that I have. Payload 3. So this is going to give us the window location. Oops. So the window location is about blank. This is important because of the same origin policy. I told you that if it's a file name, a local file name, we will be able to read files from the local file system. If it's about blank, that's not going to work, so we know that we don't have local file read, unfortunately, which would be a quick win for us, but that's not the case. Then, payload 4, that I haven't shown you yet, is basically pointing to the cloud metadata service under that URL. And as you can see here, in an iframe, there is this sad emoji, so it couldn't load. But that's not going to work. It's not running on EC2, so that's not that surprising. So next slide. On gPC Azure, again, it's the same IP. It's a little bit different. You need to put an extra header into the GET request. Different for Azure and GCP. But again, the issue with this for us as attackers, as hackers, that because of course it's not going to render in the browser. So one really interesting thing about AWS and ECS, Docker containers, containers in general, that there is another metadata host under that different IP, right? So you can easily open that in an iframe, and I'm going to show you. We can get the metadata. But if you want to get more juicy things like credentials, then you need to have the GUID, which is a unique identifier, quite long, for the container. And it's not that easy to get that, but if you can get it, then you can get the credentials. So how do you get that? It's basically you go into that file and you read the content of the file. But I told you that we don't have local file read. So how do we solve that? So let's see the next payload, which is 5 and then 6. I'm going to execute those payloads on the server and render it to a PDF. So this is 5, and this is a JSON content, right? This is returned as a JSON. This is the metadata for the container and the cloud and the cluster. You can see the cluster name here, which might be useful if you do attacks on the cloud environment. What else? Then yeah, so IPv4 address, that's quite important. 227. We might want to remember that that's an internal IP address that we can attack later. And let's see the, oops, not this one. Apologies. Yeah, so a lot more information about the container itself. It might be useful, it might not be useful for further attacks, but it's definitely not that great that we have that there. So what else can we do? Port scanning is one of the things that we can do. So the container is running inside of the AWS environment, right? So if we manage to discover other IPs, other ports in the same environment, which is an internal environment, we might be able to find other vulnerable services and do more harm to the environment, or we can just jump across and get more details, credentials, and so on. And that's our goal. So we can do port scan from HTML, from JavaScript, from cross-site scripting. And there is a really, really cool research under this URL done by Nikolai Chacher. I'm not sure if I said that name correctly, but big ups for the guy. He was using WebSockets and image tags to do port scanning from HTML and JavaScript. It's based on timing, so it's not super reliable, but it kind of works. And also Chrome and other browsers figured out that maybe this is not the way to go forward. So they try to fix these issues by introducing random noise, random delays into the process. So even though this is a really cool research, it's not always working as intended. But there is the old school way that you can use. You can use iframes, and you can just include different websites from the internet network into iframes. Obviously, it only works for HTTP and HTTPS, so that's a limitation. But what you can do, you can check for timeout. So let's see a demo on that. This is basically the script that I stole from the website that I mentioned. It's quite complex. There is the internal IP that I'm going to use just to speed up. I know there is something listening on that service, on that IP, on port 8080. So I'm going to execute that payload. But if you are more interested, first of all, you should read that URL that I put it on the slide. But otherwise, this is the script that I just formatted in a different way, because otherwise it wouldn't run. Okay, so let's execute that. 7. And basically it tells you that the port is open, right? So I'm not going to bore you with the port scanning bit because it takes a little bit of time. But the next thing that you can do is to read the content of that web page. So I told you that you can use iframes to do that if it's HTTP or HTTPS. So this is an iframe pointing to the website. It's like a CTF right now. So let's just do 8. And I do 9 as well, just to speed this up. And 8, it basically shows you the content of that website that we found on the internet network. And it says, that's why I said it's like a CTF, I give you the answer for the next step. Basically, there is an endpoint called LFR, local file read, where you can specify the file name. So what I'm going to do, I'm going to try to read the etc password file from the Docker container. Let's see whether that works or not. I already executed the payload, so payload 9, and you can see that returned the etc password file's content, which is quite good. So what would be the next step? Right? We want to read the proc self environ file because that has the GUID for the container. So payload 10 is putting the same website into an iframe, but with a different file name. That proc self environ contains the GUID that I mentioned to you, and with that GUID we can get the session token and other stuff as well. So there you go. This is the content of that file, and here it tells you that AWS container credentials relative URI is under that one. So I'm going to copy that. This is the GUID. I need to make sure that it's copied properly because it's not always working like expected. Okay, that looks good to me. So other than reading local files, you can do SSRF with this service. And I mentioned to you that ECR, ECS, has a different metadata host, IP. And that's the IP for the metadata, if we are talking about ECS. And under that, if you know the GUID, which we got from that local file, then you can get the juicy bits, the credentials. So I just executed that payload as well. And there you go. If you are familiar with this, basically this is what you get back from AWS if you're lucky. It has quite a few things. Let me just copy this. We need to format it. So there is the access key ID. And we have the secret access key. So those are the main things that we need, and the token. So the token is a bit badly formatted because of the new lines. So I need to format that, which takes a little bit of time. Okay, that might be it. Just give me a second. took some time. Sorry about that. What happened here, basically I exported everything in my console so I can use the AWS command to do anything on the cloud that I can do. And here I use the STS getCaller identity command, and you can see that I'm basically logged in. The next step would be to figure out what I can do with the cloud at all, because it might be restricted. Usually it isn't. So let's just see. So there is this really cool tool that you can use to enumerate your credentials and your roles and policies in AWS. You can see that basically I have access to everything. Including S3, so I can read the buckets, I can list the buckets, I can create new buckets, download files and everything. There is only one bucket here, which is called only for admins. We are definitely not admins by default, but with these credentials we are. So yeah, I can list the content of that bucket as well. There is a secret.txt file. I'm really curious what's in that secret. So let's just try to get it. And basically, the content is, I hope you like the presentation, AWS owned via server-side cross-site scripting. Yeah, so that was the demo. Thanks for coming along with this. Basically, the last bit I want to talk about is the mitigation bit, right? How to fix these issues. I already mentioned to you that to fix basically any kind of injection attacks, but specifically cross-site scripting in this time, you need to implement one of the three input validation. One of the following three things: input validation, input sanitization, output sanitization. If you have at least one of the three, you are going to be fine. You don't need to worry about this kind of issues. On a high-level approach, you can do more than that, and you should do more than that. So first of all, you can do and you should do threat modeling, where you sit down, you think about the issues that might happening with your solution. It doesn't have to be this exact solution, anything in general. So you just think through, if you were an attacker, how would you attack the environment, what would you do, and you need to consider different angles here. When you have all the angles that you can come up with, you need to find the mitigation techniques that you can implement or the fixes that you can implement. If you do that, you are going to be more protected than ever. There is the least privilege principle and separation of duties. These are really important. You could see that this cloud user that I used, that I abused, had access to everything, right? So obviously it doesn't have to access everything. Why would you need access to S3 and EC2 services in AWS if you are a Docker container? That's very little, it doesn't make too much sense for me. And the separation of duties as well, if you have two different roles, you shouldn't merge it into one user. You should use two different policies, two different users, just to make sure that even if one gets compromised, it won't be able to abuse the privileges, the permissions that it was assigned to, right? And defense in depth, so segregation, firewalling. In this case, the container had access to the public internet. You could download everything. You could load, render any websites from the internet. And also, not just from the internet, but from the local network as well. Why does it need to have access to the metadata? Why does it need to have access to other local services? So if you had proper segregation, if we had proper segregation in this case, then we wouldn't be able to access the other Docker container which was vulnerable for local file read and server-side request forgery. Back to the HTML to PDF, I kind of gave you already answer to this, what you can do with this to make it more secure. First of all, you should reconsider using these kind of technologies in full. It's really hard to make them secure, and probably the best way to go forward is not to use them at all. But obviously it's not the case, not always the case. You can't just drop a feature request whenever you like. So what you can do in the Chrome browser, you can disable JavaScript. That's going to help big time. You can configure like in general settings to make it more secure, and you should run it in fully isolated, segregated firewall environment, as I mentioned before. And you can do HTML with embedded stuff, so even if you need pictures, you can embed it into the HTML, so you don't need to have access to the public internet or to the local network. You can put everything in one file, in one payload. And if you can do that, do input validation and sanitization, but I think I mentioned that too many times in this presentation already. There was this other container which had the local file read. I put that there because I wanted to make a nice demo, show you the full attack chain from one cross-site scripting which has usually no impact. Basically, you can own the whole cloud environment, and this happened previously. So even though this is a made-up environment just for this presentation, I had this issue, like the exact same issue in the wild, and I could own a few companies like this. So that was the presentation. If you have any questions, I think we have time to do that. Nick?
Thanks, Balazs. That was really interesting. In terms of detection for this, are the normal burp fuzzer payloads enough to bring back something that will let you know this is there? Or would you need to provide your own more specific payload?
Sorry, I missed the first bit of the question. So what about the detection?
For detection of this, are the standard burp fuzzer payloads enough? Or would you need different,
that kind of detection,
customized?
Okay, so I thought that different kind of detection. So if you are an attacker, whether you can find it with automated tools, that's a question, isn't it?
Yeah.
Yeah, I'm not totally sure whether you have this in burp. Well, basically here you had a JSON payload, and also I'm not sure whether burp can render and detect PDF content, so I would say no, you wouldn't be able to access it. You wouldn't be able to detect it with burp by default. Thank you. Any other questions? No? Oh, thank you so much for coming. It was a pleasure to be here.